We're going to go on to our next speaker, to the TEDx stage, and the question is simply to keep in your mind is, how can sharing change things? Next TEDx speaker, Joichi Ito.
Hey, thanks. Hello, I'm Joichi Ito, and I'm going to explain. I'm going to talk from two different hats. Originally it was going to be just about sharing, but I actually moved to Dubai in December of last year. I was supposed to be more moved, but my apartment was about a year late, and I'm going to get it in November. And that was the first word I learned, inshallah. So I think, so inshallah I'll be a Dubai citizen soon, or Dubai resident soon. But as I got to Dubai, I realized that there were some really great things and some things that needed some work. The reason I moved, one of the reasons was this is the place that I found the internet and openness reminded me of when I was young, as some of the other speakers today. I'm 43 years old, which is 1 year past the average age of Japan. So I started to get this middle-age crisis and decided I have to get out of my comfort zone. So I moved to Dubai, and I am now out of my comfort zone. But I'll talk a little bit about my comfort zone. So I grew up in Japan and the US, going back and forth. And my venture capital I do very early stage investments all over the world, in Silicon Valley and the rest. The most recent lucky investment I did was Twitter, which I'm happy that everybody's using right now. And then the other part of my job is to work on the open standards that build the internet. So I'm from the internet, and we're here to help. So first of all, I want to explain a little bit about the basics of investing, because investing in venture capital and investing in other things is slightly different, but they have a basic, fundamentally similar premise. So first of all, as everyone knows, you buy low, sell high. Now, this may sound easy, but it's really important to understand that risk, everything has risk, right? And the trick is, how do you figure out whether this risk and the price attached to this risk is cheap or high, right? So if you are good at something, like good at understanding startups, good at understanding architecture, you may be able to, before everyone else, realize that the risk is underpriced. So you buy it. So you know the entrepreneur, you know the space, you're excited about it, and then you invest in the company. And then as the company hits the newspapers and it becomes famous and everybody wants to buy it and it goes public, that's when you sell. So a lot of Japanese, when I asked the Japanese government when they were starting to buy stocks, is how are you going to pick the stocks? Oh, we'll pick the safe ones, the ones with no risk, right? Well, that's the same Japanese who bought the Rockefeller Center and then sold it for 1/100th of the price or 1/1000th of the price. The thing is, the minute it's in the newspaper, in investing we say the information is in the price. That means that everybody wants to get in, and the price usually gets inflated. Well, guess what? There's somebody that's selling when everyone is buying, when it's in the newspaper. Well, it's the guys who bought it before it was in the newspaper. So smart investors buy low and sell high. Now, what this means is, in startup space, as we heard from other people, there are lots and lots of startups who no one wants to invest in because they don't understand. Well, that's when they're underpriced, right? And the minute everybody wants to get in, like right now with Twitter, the price is getting maybe not overpriced, but the right price, right? So I think the key to the key to understanding buy low, sell high is focus on the areas that you understand, take aggressive risk. As long as the cost of the risk is cheaper than the real risk, over time you will make money, because then eventually the price will be at the right price to sell the risk. And so let me describe a little bit of the differences, though. In a traditional company, in traditional business, you have like some kind of percentage revenue growth over time. So if you're running a big company, you try to sell, you try to increase revenue, and it grows up at some level. But you have an infinite, unlimited downside risk. If you get a project and you don't deliver on time, it could cost you more money than the revenue that you're getting. If something happens, a catastrophe, markets change. So downside risk is unlimited, and upside risk is limited to some growth of the market share or some change in your pie. And so most people who are from traditional businesses are very focused on the cost, right? Because the cost of doing everything is so high, and the upside is limited. Venture capital is very different. Venture capital, if I invest $5 million, the most I'm going to lose is $5 million. The bottom is capped, especially if it's a smart VC where you're not hiring tons and tons of people. Basically, the downside is capped, whereas the upside is almost unlimited. So if you invest in a Google or invest in some of these Yahoo, eBay, any of these guys, you're going to get 100,000 extra money, right? The trick is, how do you get into those deals that go off the charts, that knock it out of the park? It's by betting on a lot of the deals. making sure you get invited to the party. Now, this is a kind of interesting thing. There are a couple of assholes in Silicon Valley, but most of the successful people are actually really helpful, really nice guys. Because when you think about it, when we do an investment, if we are trying to figure out who to bring into Twitter, if we're trying to figure out who to bring into a new deal, it's like, who do you invite to the party? Because there's not enough room for everyone. It's like a TED. You have to find the best people. You have to get all the right people there. And so what you do is, over time, you start working with the other investors, and you say, okay, which of these investors that I work with that really help the entrepreneurs, that provided value? So I'm the Japanese guy, I'm the international guy, I'm the early stage product guy who kind of understands sort of games and addiction. So when they need somebody like that, they invite me to the party. The trick is, for venture investing, is you focus on providing lots of value, being a nice guy, and the other part is this downside is capped. You can take the entrepreneur who's failing and push him against the wall and shake him all you want, but you're not going to get that much money back. So you shouldn't focus on trying to minimize your losses. It's about, if something's failing, let them move on, get out of it, move on to the next thing. There are some big venture capitalists in America who, if they're not successful, they get off the board, convert their preferred shares to normal shares, say, good luck, see you later, and they just move on to the next thing. Because the problem is, a lot of companies, especially I see in Japan, I see also in the Middle East, they're so focused on protecting this downside, they spend 90% of their time on the failing companies. And the good ones, oh, they're doing it, okay, fine. No, that's the wrong thing. When some company is doing well, you should be spending 90% of your time on the 10% that are doing well, and let the other guys start something new and let them go. And don't try to squeeze them for success. Now, it's different. Before you make money, those guys that were spent 7 years developing the plan, that's fine. It's good to spend a lot of time developing a plan and iterating. But as an investor, what you have to do is you have to focus on the success. And when you bring an investor in is when you sort of have that angle. The other thing that's really important, and we'll talk about this next, is the cost of failure is very low in good startups, right? So now with the programming languages and with the fact that you can get cheap Chinese cup noodles and Kool-Aid, you can go for a long time without that much money. And if you look at open source, and if you look at all these different things, the cost of failure has gone down, right? So in Japan, trading company, when you do a deal with them, they have this thing called a feasibility study corporation. They spend about $3 million to figure out if they want to do something, right? And then the average telco, to swing the bat once, it costs about $100 million. You know, maybe for a big electronics company, about $10 million. Well, my average investment is about $100,000. The average cost of a startup in open source is almost zero, right? And if you think about, like, if you look at Linux, Linus Torvalds, when he started Linux, wrote to Usenet, oh, I'm going to do an operating system. I don't know how interesting it is going to be, but maybe you can join. Probably hundreds of people posted that day, opening a new open source project. You would never have guessed that that was the one that was going to become the big winner, right? And the thing is that it didn't matter. 99-point-something%, but 99+% of open source projects are complete failures with no one using it. But the thing is that since the cost of failure is so low, you can experiment with everything. The problem is, if you're in a big company and a big research lab, you have to spend so much money trying that you can't take risks. So would you have funded eBay or Amazon or any of these companies if you were in a big company? No. That's because if you can lower the cost of failure, you can try new things, and most of the really successful things in the internet space you would not have predicted had a very high likelihood of success. And it's really also really important to notice the venture capitalists only talk about their successes. We don't really care about the failures because everybody's allowed to fail. As long as you have a couple of successes along the way, then you're good to go, which is, again, another problem that we have in Asia. I don't know so much about the Middle East, but there's a huge kind of stigma to failure. But that shouldn't be the case. It should be that you should just keep trying until you get one. And this is also the point about iterating. You know, a lot of companies can change their business model as they go along. This is also very important. But lowering the cost of failure is very important. And part of this has to do with the standards. So the old way of doing standards, now I'm going to use American paradigms, but East Coast American, and then if you look globally, the telephone companies used to run the network, right? And they had big research labs, and they would go to these big intergovernmental standards bodies wearing business suits and spend years and years and years and years coming up with these standards with PhDs and all these people, and then they would create these standards that are about this thick that require thousands of people to develop, and then they would outsource them to big contractors who would supply this. It was important because we didn't have agile, rapid standards development. So this is how the telephone networks were built. This is how GSM was built. This is how most of the network and information technology was built until the internet came along. What happened with the internet was we got into this whole open standards. So David Weinberger calls this small pieces loosely joined. So instead of big, huge chunks of lots of smart people with lots of funding, the internet was about lots of little groups connected together loosely around open standards. And the standards weren't decided by these places that were populated by big companies and governments. It was 12-year-olds, 13-year-olds who could go onto the mailing list. Anyone can participate. Anyone can add to the standard. And we had the Internet Engineering Task Force had a credo called rough consensus running code. So basically, instead of trying to anticipate every single problem, you write some code, and you talk about it, and you work on it, and you work on it. And sometimes you get some mistakes, like we didn't really anticipate spam, and we didn't anticipate some of the security issues. But it was still much better and much more robust than you could have expected. This is what we call the stack. Now, for the technical people out there, you'll see that this isn't completely technically correct, but roughly I'll explain. These are the open standards that make up the internet. The top one you might not be familiar with. But if you look, they're very important. So when Ethernet first came out, it's the thing that connects these computers, that cable that you see in the network protocol in it. Before Ethernet, you couldn't connect a Mac to a PC. I guess you guys are all young here, so you don't remember, but I couldn't connect my Mac to my PC. I had Apple Talk, and I had this Microsoft connector. Well, Ethernet wasn't the best, smartest protocol. It just didn't have intellectual property encumberment. It was an open standard, and we have one of the sponsors, I think Cisco, and all these guys could create all these routers that connected everything together, and we created an open standard. TCP/IP was a network layer on top of that allowed the computers to talk to, like, address each other. So if you remember, again, maybe, I'm sorry, I keep forgetting that the average age here is much younger. But back when I was a kid, your Macintosh, even if you connected them, couldn't talk to your Windows machine. And I remember downloading free TCP/IP to both my Macintosh and my Windows machine, and suddenly they could connect together. My computers could connect together. They could connect together with everywhere else on the internet, and it became one big network. Now, neither Ethernet or TCP/IP was the smartest, most clever system, but they weren't protected by copyright. They were run by open standards bodies that were non-governmental and ad hoc. And for a while in Japan, it was called illegal to do internet. I started the first commercial ISP. I was the CEO of the first commercial ISP in Japan. And they kept trying to shut me down. It was a political war to win internet. So internet at the beginning was a struggle. Now everybody uses internet, and you don't think of it as something that we had to fight for, but we actually had to fight to bring internet to the world. HTML was a little bit easier when it first came out. Everybody sort of yawned and said, well, why do we need that? We can already log into the databases and get all the information. Why do we have to make it easier? Well, it turns out making it easier created this explosion of innovation that we couldn't have anticipated. When the web first came out, most people didn't really understand how much impact that would be. But again, very important, not patented. Tim Berners-Lee could have tried to patent and sell this thing, but the founder of the World Wide Web Consortium that created HTML, he gave it away for free, created an open standard so that everybody can participate, and this created this whole layer of innovation. So what you see about the comment about these three layers is they're open standards, they're not copyrighted, and it creates this environment of small pieces loosely joined because of these standards, you and I can create tools that automatically work together. It's called interoperability, and we don't have to control the whole network like the telephone companies used to do. We can just do our part, not know the whole of the network, but it all kind of works together in this kind of ecosystem. It reminds me a lot of an ecology or an ecosystem. So what I'm saying right now is that Creative Commons, which is the new project that I'm working on, which I think is the next layer of standardization, is that now that we have these networks together, what is the failure? Just like we used to have a software engineer and a network engineer to do everything, right now we have to have lawyers every time we want to do anything at the content layer. If you're a Croatian professor and you want to share your courseware with a Japanese professor, you have to go and hire a lawyer on each side to create a contract. If you add a third school or fifth school, then suddenly the cost of the lawyers exceeds the value of the transaction, and we call this failed sharing. So back before, when you used to go and fly to Cannes and drink champagne, I used to work for a television company, so we used to do this. The legal fees could be $10,000, $100,000. That was fine because it was a $10 million, $50 million deal. Now, the people who are collaborating on eBay, not on eBay, I'm sorry, on YouTube, they can't afford these legal fees. So what I'm trying to do is create a layer of standardization of the contracts for the lawyers to allow people to share with each other. And I think that that will cause an explosion of innovation just like these other layers of openness have done. And also just since Google, I think, is here, if you think about Google and imagine, so Google used open source, they used basically mostly standard PC, and they just connected it to the network at Stanford. So it was google.stanford.edu. Before that, before the stack, we used to have what we used to call X25 was a network where you had to have, every user had to pay for traffic. You had to have a bilateral agreement with every country that you connected to. And if you imagine that PC being replaced by a big proprietary mainframe, probably Google would have cost hundreds of millions of dollars, taken 10 years, run by the telephone company, it wouldn't work, right? And the fact that Google was probably, the first server was built for thousands of dollars and connected at no cost to the network, and suddenly the whole world could access this. It's this beauty of this stack. And this goes back to the earlier point, lowering the cost of failure, because the Google guys actually, I remember I was running InfoSeek Japan, they came and tried to sell us an algorithm. And they said, oh, screw that, we're doing it on our own, right? And so they did it on their own, and they were successful. That's really the key to innovation, and that's why the West Coast in the US is beating the East Coast in the US, because innovation is no longer in the big companies, it's in the little guys, and I think Google is doing a very good job of trying to keep that spirit going inside of the company and trying to reinvent how big companies work. But this is very, very important. I think that people read about this in the news, but you kind of have to understand this as almost a belief system before you can really monetize this and create this. And so I'll talk a little bit about Creative Commons. This is my big mission right now, and one of the reasons I moved to the Middle East is this Middle East and Africa is the last area where we're trying to get adoption of the licenses. But we asked a bunch of creators, what are the questions that you want to answer or express when you mark your works? So if you're a photographer or a professor or somebody, a writer, blogger, what are the things that you want to be able to decide about how people use your work? So we found that over 90% of people wanted attribution. So if somebody uses your work, you have to say it's from Joichi Ito. Okay, fine. Some people said, if you create a derivative work, if you remix it, I want to have it shared back to me. So a lot of musicians say, okay, fine to remix my music, but I want to be able to use it too, put it in my CD. So that's the share alike. So Wikipedia, for instance, is share alike. You can use their work, but you have to share it back. Non-commercial. Many professional musicians say, okay, you can share on the file sharing networks, but if you're going to use it for commercial use on the radio or in a CD, I need to get paid, so I want that reservation. The other one is no derivatives. So I think TED conference, the videos are non-derivatives. When you're trying to tell a story, a lot of documentary people say, no, I don't want you to remix this. This is the story. So you have So we said that if you select answer these questions, you get 6 basic licenses, which encompasses 90% of the things that most people care about. So obviously, Hollywood and some of these people who make a business out of, they already have maximum demand and just need to protect. They keep the all rights reserved. But many, many people in the world, like amateur photographers or professors or bloggers, want what we call some rights reserved. And the key is that by marking your works with these icons, we create licenses in 51 different languages so that people can use these works without asking permission. So Obama's pictures were licensed under our Creative Commons licenses, and a broadcaster in Japan wanted to use one during the inauguration. Well, they can use it without sending a fax to the White House and getting a fax back that says okay, because they already know that Obama says it's okay to use it. And Obama's like, okay, of course you can use it because we know, I mean, I'm happy for you to use it. So in cases where you want to give permission, and you want to create distribution of your work, Creative Commons licenses are good. Just to give you a couple of examples, so exactly at noon when Obama was inaugurated, they updated the White House page, and they put Creative Commons on the White House page. So any content that a user uploads to the White House page gets a Creative Commons license that says that anybody else can use those comments as long as they provide attribution. Wikipedia, it took us about 4 years, but we finally converted Wikipedia to Creative Commons license. Now, to explain a little bit about why this is important, is Wikipedia was created before Creative Commons, so they had a different but very similar license that said you have to use it, couldn't share it back. But this reminds me of the early days of the internet. It was a slightly different license than the Creative Commons license. So the MIT professors who used Creative Commons licenses couldn't remix their content with the stuff that Wikipedia was using. So even though it was the same idea, because they were different licenses, you had them separated. And by converting Wikipedia to Creative Commons, we create one body of work. And this is why Creative Commons and me pushing may sound a little bit imperialistic. But it's important, just like we don't want 5 different internets, we don't want 5 different standards for this interoperability at the legal layer. It has to be a common language so that all the lawyers are talking about the same thing. And that's why we have people in 80 countries giving us feedback so that we can modify the licenses. We're just about to launch the first Arabic license in Jordan in next month, so that's a big deal for us. Thank you. Actually, the first commercial broadcaster, professional broadcaster to put broadcast quality footage online was Al Jazeera, which was great. And many, many broadcasters use their content, like Rai in Italy and others. And they've told me that because they gave this stuff away, just like TED gives their videos away, they got so much recognition that they actually increased their sales and developed commercial relationships with a lot of new distributors. 9 Inch Nails is a band, but they gave their Ghost CD from last year away. So they said you can Creative Commons attribution non-commercial share alike basically means you can reuse it for non-commercial use, you can remix it, but you have to share it back. But they sold a limited edition box set, a picture book, DVDs, and they made $1.6 million on this website in the first week, right? So this is a big shock to the music industry. You're giving the music away, and you're making all this money on this other stuff. And this is a really important thing, is that you can actually, there are businesses built around sharing. And so I'm not going to go deep into this, and there are a lot of case studies. Publishers like Bloomsbury Academic in England, many big commercial entities are starting to use Creative Commons. Ridley Scott, the famous director, is going to do the prequel to Blade Runner under Creative Commons license, so other people will write other stories about the same characters and reuse his work, because he wants to create a universe on the internet, not just his own narrow thing. And so that's kind of roughly what Creative Commons is doing. A really important other piece of this is the World Wide Web Consortium. So these are the guys that create HTML and manage that process to create that standard. We created with them a standard to put the copyright information in the HTML itself. HTML is the metadata and the way you tag stuff on the web. What that means is that service providers like Yahoo and Google and Microsoft can now understand copyright information. When you copy-paste stuff from websites, it'll bring the copyright information. Actually, if you go to Google or Yahoo, you can go to advanced search and say, I want pictures of Burj Dubai that I can use for commercial use as long as I provide attribution. They will look at the metadata of the Creative Commons license and find it for you. Eventually, this will be built into all of our software tools in our network. But it's very important, again, to try to keep this technical layer together, because the technology and all of the people who are using that again is trying to lower the friction so that the software and the network understands copyright, so you don't have to hire lawyers to try to understand it. And I think that most people fail to follow copyright, not because they're criminals, not because they want to stick it to the man, although some of them do. It's usually because they're lazy. And I think that once our tools are aware, it'll lower the friction and make it a lot easier. Which segues a little bit into this development model thing. This is a little bit technical, but I want to describe it, because these are some keywords that will come up. But the waterfall method is the old way of doing software. This is when things in the world didn't change very much. So what you would do is you would write the requirements, design it, build it, implement it, verify it, and support it. And this would take years to develop, and then finally you'd get it, and you have this huge thing where the cost of changing anything was very, very high. So cost of failure goes up, speed goes down, and you don't want to change it. And this is how most systems work, and it's kind of how, when you build a big building here, this is how you build it. In software, it doesn't really work. In software, we do what we call agile development. And so you look at Twitter, Facebook, all these guys are doing this. This is basically, we call them sprints. So each rev is about 1 week, or maybe maximum 2 weeks, sometimes less. And what you do is you plan a little bit as what you can do in a week, lots of what we call stories. You write the requirements, and these developers get together, and they write it, and they test it, and they write all these tests around it to make sure it does what it does, and they evaluate, and then they keep spinning out a new version every week. And then suddenly what happens is change is built in, and you create a system so that the business people and the designers that are all involved in this process, so that suddenly says, when it says, oh, wait, Twitter just came out, what are we going to do about that? Well, it only takes you, the maximum delay you have before you respond is a week. Whereas before, you would build something that's 2 years late, that's completely irrelevant, and unable to respond to anything that's happening in the real world. this is what most of the good software companies and startups in Silicon Valley are doing. It's not that hard. It's, again, a paradigm shift from the way you used to do work, where you kind of toss things to system integrators. Well, this is not that hard to do, and this is something that I think we need to bring over. And then one other part that's very important, which I think is just a way of thinking. Virality is one way to explain it, but distribution and getting users. So everybody says, oh, what's Twitter's business model? You know, well, if you look at Google, any of these successful companies, have you ever seen a company that had 100 million users that couldn't figure out their business model? Maybe Napster had some problems. There were